Alright, so today's lesson is going to give you guys a chance to revisit and reinforce what's important in terms of what you've learnt so far from your algebra unit. We've been through adding and subtracting like terms, and we've done index laws, which is mainly involved with timesing and dividing our algebra together. So we're just going to go back over those two things today, those two ideas that we've learnt, look at what they've got in common, what they've got different, and just make sure we don't get kind of the algebraic methods that go with each operation mixed up. So when we plus, we do something different than when we multiply. We don't want to be getting kind of the different notation for our algebra mixed up between plussing and timesing in particular. So we'll start by just looking at multiplication. And with multiplication, when we're simplifying our work, because all of this algebra is really just about writing something that looks complicated in an easier to understand way. When we're multiplying, we're happy because we can kind of multiply and simplify with any letter, any variable we want. We kind of just smush them all together. Okay, we perform our simplification. We group the variables together, right? We put them all next to each other, and then we start working with powers. Because powers are all about timesing, right? If you see a power, it means that your variable is multiplying itself, right? So there's already timesing involved. So that means when we're multiplying or dividing, it's going to be the powers that we start working with. We won't be putting numbers out the front necessarily unless they're already there. So let's have a look at a few examples of that. All right, so when we're dealing with a string of letters or variables and they are being multiplied, essentially the main way that we simplify them is just by getting rid of all the time symbols, the multiplication symbols, because one reason is that the multiplication symbol looks suspiciously like the letter X. And we do not want people mixing up our multiplication symbols for the letter X. So the shorthand for multiplication is to just put things next to each other. So A times B is the same thing as AB, right? By putting something next to something else, we're implying that they're multiplying. So this really means A times B. And if I asked you to turn A into a 2 and B into a 3, you'd just go 2 times 3 and you'd get 6 because they are next to each other. So that's just going to apply to when we've got even more letters involved and they're all together. So here is AB. It's already A times B. Now we're timesing CDE. So you just smush them all together and you've got A, B, C, D, E. When we get numbers involved, we worry about them as well and we put them at the front. So look, I've got letter A, letter B, letter C, letter E. Everything's either next to each other or has a multiplication symbol in between it, which means everything here is multiplying. So we need to put any numbers at the front, any coefficients. So we have a 5 at the front, and then alphabetical order is always best, so it's A, B, C, E. Okay, and even when it starts to get more complicated, I've got combinations of numbers, different letters and powers. We just try and smush and put things together when possible. So the 5 and the 2 can go together. They're numbers. We know how to multiply numbers together, which means we'll be starting with a 10. We've got an A, we've got a B squared, right? It's still part of it. Just leave the power alone. There are no other B's to put with it. We've got C, we've got D, and there's a potato at the end because it's multiplying. So we just put it all together. Everything goes next to everything else. So if you do want to get a few of the questions right today, you'll have to just remember these index laws. They're really just telling us what to do if we have the same letter involved. All of our previous examples, we didn't have any letters showing up more than once as we were timesing together. We had A, B, C, D, E, all different, but it's just worth remembering that when you do have the same base or the same letter with powers on them, that we can apply our index laws. And that's really just asking, like, how many repeated multiplications do we have, right? B squared means B times B. B to the 4 means B times B times B times B. So we can write a new power on our B. We can combine them and simplify them by putting a 6 there, right? 2 of them and 6 of them, 2 of them and 4 of them make 6 of them, and they're all being multiplied together. That's what powers are, right? Repeated multiplication. So a B times another B is B squared, right? When we're multiplying, we can play with powers, right? There's no number out the front. We're playing with powers. Powers tell me how many things I've got multiplying. And divided by is the opposite. Right, I had 4 b's all being multiplied. B times B times B times B. Divide out a couple of them. And that leaves us with 2 because we took away the powers from each other. Right, so if I had 16 b's all multiplying each other, b is multiplying by itself. It's b times b times b times b times b, etc. 16 times. I divide away one of them, which is what I've got here, because there's no power being written, so that means it's just 1. I'd be left with 15. Right, this lets us sort out when you've got the same letter showing up in your work more than once, which is going to happen as you go. Right, so what we've got on this screen, it's a bit busy, but we've got some timesing, dividing, plussing, and minusing. We've got all our 4 basic operations, all having algebra applied to it, and it's really worth noting that they work differently. Right? You can't do what we do for multiplication with addition, right? There's different rules involved. So since we've been talking about multiplication, we'll go through these examples. They look pretty full on, but essentially all you've got to do is be really methodical and worry about one letter at a time and numbers as well. So we're going to start with numbers, right? We've got 2 big terms being multiplied together. So we're going to follow our rules of multiplication, right? We're going to multiply the numbers because numbers just multiply like numbers, right? 4 nines is 36. We put it at the front. Then we're just going to worry about one letter at a time. So we really want to know how many A's are repeatedly multiplying. Right, I've got 2 here, I've got 3 there, that makes 5. With my C's, I've got 2 there and 2 there, 2 plus 2 is 4. With my K's, I've got 3 here and 3 there, which means there are 6. Right, this is what effect multiplication has. Right, we can times numbers together, but when we're working with variables and with powers, we're adding those powers to show how many of those letters are multiplying themselves. So same thing again, I've got a 6 and a 5, that makes 30, because these are numbers, they're not powers. Right, we've got the letter K in both, so we can put the 3 K's here with the 3 there, give it a power of 6. With the P's, I've got 3 here, 2 there. That makes P to the power of 5, and then R has the power of 6 as well. Okay, so with the last one here, I've got the number 6. I multiplied my coefficients there. H gets a power of 2, because there's 1 here, 1 there. So does U, we got U2. And X gets a 6, right? And that's all we need to do for multiplying. If you've got the same letter, their powers get combined. Otherwise, you just put them as part of your work. All right, so if multiplying gives me more powers and lets me kind of add up the number of letters I've got, then divided by does the opposite, it gets rid of letters. So you're going to be cancelling out a lot of stuff when you get divided by questions. So we'll start with the numbers. Right, we can just go 54 divided by 6. That's a number. There we go. 54 divided by 6 is 9. And then we should be looking for things in common across our 2 terms. And the easiest way to think about dividing is things are going to cancel each other out. So if I have a b in this one, and I divide away that b, it basically removes it from the answer. And the same thing's going to happen with c. They cancel each other out. The only thing that didn't get cancelled out then in that process is the letter A, which means it should still be part of my work, part of my answer. So 54 divided by 6 is 9. And then when all the cancelling is done, only the letter A survived. With the next one, your numbers aren't always going to evenly divide into each other. So we're going to be having fractions in our answers, and we'll have letters on the top and letters on the bottom sometimes. So 11 divided by 3, if you put it in your calculator and make it set a fraction as the answer, all it gives you is 11 divided by 3, just written as a fraction, 11 on top of 3. So that's how you should write it. We like writing fractions when we work with algebra. Then we're going to look at our letters and see what cancels out. So the y's cancel out really nicely. 5 y's in this one will cancel out 5 y's in that one. I started with c to the power of 6, and I'm dividing away c to the power of 5. So starting with 6 and getting rid of 5 leaves me with 1. So we put it on top and we call it a day. Now with the last one, 8 over 10, we're going to put that as a fraction because it's not even. We can't evenly divide 8 by 10, but it does simplify down, right? If you don't know how to simplify fractions, your calculator does. It makes 4/5, and that's basically because we just halve that and halve that as well. We're just looking for numbers that go in evenly. We divide them out. And then what's going on here is the bottom part is kind of where I'm dividing, right? That's where that 10 went. We're going to try and cancel out what we can. So looking at the z's, I've got 3, and I want to divide away 6 of them. So essentially, I can cancel out these 3 with 3 of those, right? That leaves me with 3 lots of z still to be divided away. So I need to put that down the bottom of my fraction. The other way to think about it would be, I can take away the powers. I would have got z to the power of -3. And when I get negative powers, we put them on the bottom of a fraction, and they're not negative anymore. So the same thing happens with u. I've got one of them to cancel out, but I can't cancel out the rest of these, so I'm left with u6 down there. All right, so divided by is the trickiest one, I reckon, but think about cancelling, and if you can't cancel things from here, put them on the bottom of a fraction, and you might be okay. So just to contrast that and make sure you don't mix up the maths going on here when you've got pluses and minuses going on in your work, I thought I'd just show you a difference between them. Okay, so multiplying and dividing is all about playing with powers. That's why we spent a week doing index laws, because when you're timesing, you're adding to powers or taking powers or doing other things with powers. Uh, Plusing and minusing does nothing to powers because powers are all about timesing. Okay, they've got nothing to do with plusing. All we have to remember with adding and subtracting is we can only add and subtract things that are identical in terms of the letters, the variables, and the powers as well. So I can't actually add x and y together. I'm not going to smush them together. I'm not going to turn a 7 and a 3 into 21. I didn't get asked to multiply these numbers together. All right, this is basically 7 xylophones and 3 yachts. You can't add xylophones and yachts together. So this would be as simple as it gets. You can't actually cancel that down, right? That is as simple as it gets. Same thing here, x's and x squareds are different things. They have different powers, so I can't add them together. I can't actually do anything with these. So again, this would be as simple as it gets. If you had this like in your working out, you wouldn't do anything else to it. But the third one, I'm dealing with x squared, right? Both of these things are about square xylophones, square x's, so I can add them together and write down how many I've got. And that's now we can add these front numbers because we're working with the same types of letters. So 3x squared and 4x squared makes 7x squared. All right, some of you will be tempted to try and put these powers together now, but that's what multiplication is for. Multiplication lets you change powers. Addition doesn't. It changes numbers at the front, and we're really just writing down how many of a thing we've got. Same thing for subtraction. These are okay to subtract from each other because they're both y squareds. That is the same type of thing. So we're just asking how many. And any time in life, if I have 7 of something and I take away 3 of it, then I've got 4 of that thing. And in this case, the thing I've got is a y squared. And with the last one, I can put these two terms together because they have the same type of letter, but I can't do much with this. So to simplify this one down, we can take away the x squareds from each other. Right? 8 take away 4 leaves me 4. And then this has nothing to do with x squared. It's still part of my work. So I'm going to put the minus 4y's as another part of my answer. And then we're done. All right, so timesing and dividing behave very differently than plusing and minusing. You've got to remember what happens when you're given particular operations.